So my name is Courtney. I am one of the student recruiters for the Faculty of Science here at the University of Alberta. And I'm joined by Professor Marie-Jeanne Gras, who is a paleontologist and Associate Chair of the Department of Earth and Atmospheric Sciences. And today we're going to talk about the different degrees available within the Department of Earth and Atmospheric Sciences. So the environment around us is rapidly changing. Violent storms and flooding and bitter cold snaps like the one that we just experienced, large city buildings creating heat islands, then made worse by continuous heat waves, natural resources being tapped out and alternative solutions needed, permafrost thawing and exposing fossils, but also dangerous methane and CO2 gases. So your generation is living at the heart of this climate crisis, which can be a little bit frightening, but also motivating in demonstrating the importance of studying the Earth. So future geoscientists like yourself can be at the heart of understanding these challenges and finding sustainable solutions for generations to come. So before we begin, I would like to acknowledge that the University of Alberta is located on Treaty 6 territory and respects the histories, languages, and cultures of First Nations, Métis, Inuit, and all First Peoples of Canada, whose presence continues to enrich our vibrant community. The Department of Earth and Atmospheric Sciences is one of the largest and best supported departments of its kind in Canada. We are actually #1 in Canada for our earth science programs, with our geology programs ranked in the top 5 and geography in the top 10. And our paleontology program is ranked second best in Canada and number 15 globally. So our students really do have the opportunity to learn from professors who are world-leading paleontologists, geoscientists, geographers, planetary petrologists, which means space rock scientists. And these professors are recognized not only for their research, but for their dedication to teaching. And this means that you gain the most up-to-date knowledge from individuals who are excited about their discipline and are in the top of their field. One of our professors collaborates with NASA and will actually be analyzing the very first rock samples brought back from Mars, which is pretty cool. Professors are always willing to help, even though some class sizes might be large. They do have dedicated office hours to assist you with course material. And this dedication to your education does really have a lasting impact. A former student actually went on to unearth a newly discovered 90-million-year-old fossil of an ancient insect burrow, which he named in honor of his thesis supervisor. And speaking of space rocks and fossils, the Department of Earth and Atmospheric Sciences houses one of the largest meteorite collections in Canada. Our many other collections are the finest of their kind in Canada, containing millions of specimens that highlight unique discoveries addressing major evolutionary and geologic questions. So collections range from evidence of the earliest life forms and life activities, fossils from the most recent ice age, over 1 kilometer worth of drill cores and ice cores to help answer critical climate change questions, plus thousands of rocks and minerals and ancient plant fossils. So these museums and collections aid the educational goals of the department, enabling students to view and study specimens that are too valuable or fragile for handling. And these museums are available to the general public to view as well. And the UFA really does value hands-on education. So students are encouraged to take advantage of some of our unique learning sites and specialized facilities, such as the Geoscience Rock Garden, Ore Deposits Laboratory, and the Danic Bone Bed, which is Edmonton's very own backyard dino dig site, which maybe you didn't know about that. It's actually in around the Terwilliger neighborhood. So here you can find fossils of the Edmontosaurus, which dates back to the late Cretaceous period. And if you're curious about what these spaces and the museums look like, there is a link at the bottom there that you can check these out for virtual tours at uab.ca/sci-tours. And learning skills beyond the classroom allows students to gain experience that's relevant to future careers. And we offer one of the most comprehensive and extensive undergraduate field school experiences in Canada. Our students have unparalleled access to the most coveted geoscience field locations in the world. thanks not only to the university's physical proximity to unique learning sites, but also to international partnerships fostered all over the globe through researcher and faculty connections. So I will let Professor Marie Gingras speak a little bit more about these field schools. You can go ahead.
Sorry. Yeah, I'd be glad to speak about the field schools. We have a field school offered at almost every level. And EAS 110, for example, is a field school that new students who are interested in the earth sciences can attend after their first year of studies at the University of Alberta. And it usually runs in early May, just after final exams. And it's a nice trip that takes you through Jasper down to, well, I'm kind of going backwards. It actually takes you into the Drumheller area, across to the Crow's Nest area, and then up the mountain belt all the way to Jasper and then back to Edmonton. It takes about 8 days, I think, depending. And you do make a lot of field observations on the way and make a lot of really good friends. Quite often there's about 20 to 25 students on the field trip, 2 professors and a couple TAs, and it's a good way to get to know people if you're interested in geology. The other field schools are more advanced, and I think a couple are self-explanatory: geology and advanced geology, which are field skills that are required by professional geologists and expected for professional geologists to have taken by the Alberta Professional Engineers and Geoscientists Association. Likewise, environment earth sciences field study course that teaches you how to make environmental observations and measurements, such as sampling streams, sampling ice bodies, sampling sediments, and some of their subsequent analyses. You've already touched on Paleo 400. And then EAS 429 is an advanced field school that, at least historically, is run up in the Northwest Territories on the geology of the Canadian Shield. And 499 is really an urban field school. That's for human geographers and planners, which are kind of on the geography side of the department. And they go to an urban city, say an urban center such as Toronto, where they've gone in the past. They've even gone to Europe on years where there was funding for that. And they make observations about how cities are developed, run, and used by people, and they have a lot of fun. All these field schools are really good opportunities to make really close friends and to really enjoy education, kind of distilled down to what's really fundamental, which is learning things by doing things.
Excellent, thank you. Yeah, we have so many different hands-on experiences. And once you get up into those higher levels, your class sizes do get smaller. So when you're starting out, your class sizes might be quite large in your first year, but once you get up to those higher levels, like Marie said, they are smaller, and you create that close-knit community in your program. So as a research-intensive university, we want you to get involved in research. So you can work alongside top research professors in various fields who track fireballs and their meteorites, preserve fragile permafrost records in past life, and track the rhythm of climate change over thousands of years, or even fingerprint volcanic eruptions to complete climate puzzles. So many facilities support the department's teaching and research programs, such as the De Beers Laboratory of Diamond Research and Ocean Climate Modeling Laboratory. And the Department of EAS is a leader in natural resource extraction research, supporting the clean energy revolution by developing groundbreaking technology to recover lithium and other critical metals that are found in wastewater brine from oil and gas industries. So examples of recent undergraduate research projects would include biogeochemical analysis of the North Saskatchewan River tributaries, geological map compilations of the Bay of Islands in Newfoundland, geothermal potential of the Cardium Formation in Alberta, and identification of hydrothermal activity in the Chinese Chengkong volcanic area. And it's okay if you don't understand what these what these terms mean now. Once you are in the EAS program, you will definitely have a better grasp of that. And it's really important to balance your academic and social life, which you can do by joining one of the over 450 student groups that we have on campus. And you can get to know like-minded peers who are just as enthusiastic about rocks, weather, and fossils as you are. And there are 5 EAS-specific student groups, plus many others who raise awareness of the threat of climate change and organize really fun field trips.
Now let's talk about programs. The majority of programs offered by the Department of EAS are Bachelor of Science degrees with a few Bachelor of Arts degrees and range from being broad and flexible to structured and specialized. A major degree is our most flexible degree program, where approximately half of your courses are in one main subject area and the rest can be elective courses. Most students do add a minor, which then allows you to design your degree around 2 areas of interest, plus still have lots of room to add elective courses from almost any subject. An honors degree is for students who wish to focus more in depth on a certain subject area, while still having room for a handful of electives. The biggest difference is that there is an added senior research project, which is taken during the final year. And you can add research to any degree type, but with honors, it's built right in. And these students are expected to maintain higher grades than those in the major program. Technically, honors students can also add a minor, but it's best to talk to an advisor after starting your program because it may be tricky to find time to fit in all of the required courses for 2 different subject areas. Both of these degree types, so major or honors, are 4 years in length if you're taking a full course load, but can be taken part-time. If you're interested in the Earth, areas of study within the Department of Earth and Atmospheric Sciences include Earth Sciences, Environmental Earth Sciences, Climate Dynamics, Geology, Paleontology, Urban and Regional Planning, and Human Geography. So now let's look at these programs in more detail. The Bachelor of Science in Earth Sciences is offered as a major, minor, or honors. Again, honors having that added senior research component. As the #1 program of its kind in Canada, students have access to a wide breadth of courses with the flexibility to explore multiple earth science topics in all subjects offered by the Department of EAS. So topics can include evolution of the Earth and solar system, air and water pollution, introduction to mapping, or mineral and energy resources. Students can take a mix of almost any earth science, paleontology, geography, and urban planning courses, allowing you to customize your degree. In order to be successful in these courses, high school biology 30, chemistry 30, and physics 20 are required prerequisites, and I'll go into more detail about admissions later on. After first year, if you work with an advisor to choose your upper level courses carefully, you may graduate with the requirements to become a professional geoscientist. The Bachelor of Science in Environmental Earth Sciences is offered as either a major or honors. Very similar to Earth Sciences program, but is a little bit less broad. Environmental Earth Science is a study of processes at the Earth's surface involving interactions between the atmosphere, ocean, biosphere, cryosphere, and solid Earth. Humans live directly on Earth's surface, rely heavily on Earth's materials, thus influencing local and global environment. Human actions are also shaped and controlled by the geologic and geomorphic processes occurring around us. Environmental Earth Science is of global importance today and in the future as we face more and more challenging environmental issues, such as harmful chemicals that had previously been locked in ice, now potentially being released into drinking water due to melting glaciers. Courses in this program can include studying catastrophic weather events and creating a functional weather station on top of one of our campus buildings, hydrogeology and the very important study of groundwater flow systems and possible sources of contamination, understanding the chemistry of the ocean and how this is affected by climate change, as well as interpreting remote sensing imagery for terrain and resource mapping. There are 2 required field schools, plus this program meets all of the requirements set out by the Association of Professional Engineers and Geoscientists of Alberta, meaning that graduates qualify to become a geoscientist. High school biology 30, chemistry 30, and physics 20 are required prerequisites for this program. There is a wide range of career opportunities within both the private and public sector for graduates, typically with consulting companies, large resource and industrial firms, and government organizations. For example, a former student studied the impacts of climate change as it relates to road infrastructure in the Northwest Territories, and was employed with the Government of Alberta as a data and decision specialist working in the oil sands monitoring program. A minor in climate dynamics can be added to any Bachelor of Science or Bachelor of Arts degree. This minor provides a quantitative introduction specific to atmosphere and ocean dynamics and their role in the climate system. So you'll learn the foundations of computation and atmospheric physics. This minor focuses on the mathematical and computational side of climate, including thermodynamic concepts and fluid dynamics on the rotating Earth. Physics 30 in high school is required for this program, and Math 31 Calculus is strongly recommended. If you're more into rocks and minerals, the Bachelor of Science in Geology degree is offered as either a major or honors program. Geology is the study of planet Earth, the materials of which it is made, the processes which affect these materials, and the origin and evolution of life. By deciphering the processes that shape Earth, geoscientists can better understand and predict geohazards, such as earthquakes and volcanic eruptions, as well as find natural resources that can be used for green energy technology. This program shares a common framework with the Environmental Earth Sciences program, so first and second year courses will look fairly similar. Geology courses then further branch out into specialized topics such as geochronology and the study of how to tell geological time, petrology and classifying rocks, geophysical exploration techniques, as well as planetary geology and the nature of meteorites and comets. High school chemistry 30 and physics 20 are required prerequisites. Career opportunities include employment with companies engaged in exploration for and production of hydrocarbons, rare earth minerals, coal, diamonds, and groundwater. Geoscientists are also employed by consulting companies that carry out environmental assessments and remediate contaminated water aquifers and industrial sites. U of A geology graduates are found among the top ranks of major companies in the natural resource sector, in provincial and federal geological surveys, and as professors in major universities around the world. Groundbreaking innovations in geothermal energy in Swan Hills, Alberta, means lots of job opportunities in Canada's oil and gas industry. I spoke about lithium extraction earlier, and larger scale extraction is on the horizon in Alberta, but this means that environmental assessments need to be conducted in order to determine the impact on local ecosystems. This is a challenge that professional geoscientists can take on, and graduates of this program will be qualified. Our Bachelor of Science in Paleontology programs concentrate on the study of fossils and ancient animals and plants. This is an interdisciplinary program jointly offered by the Department of EAS and Department of Biological Sciences, designed to give students an immersive educational experience. Your studies will go beyond dinosaurs to better understand the evolution of organisms on Earth and their interactions with each other and their prehistoric environment, but also the earth and rock where fossils are embedded. Paleontology is offered as either a major or honors degree and is actually quite flexible in that students can take courses to focus on different aspects of paleontology, such as vertebrate paleontology, things with a spinal cord like dinosaurs and birds, or invertebrate paleontology, things without a spinal cord like trilobites or insects. Students can also focus on geomicrobiology, which looks at some of the oldest evidence of microbial life on Earth, or trace fossils, which provide evidence of burrows, footprints, and feeding. These areas are not something you need to indicate on your program application, as you can incorporate any or all of them into your degree when you're registering for courses. Other courses that paleontology students can take include learning how to properly collect and prepare fossils, understanding the mechanisms of evolution, paleobotany to study prehistoric plants and fungi, or the fascinating origin of birds and powered flight. Have you ever looked at the foot of an emu or a cassowary bird? Maybe Google that after this presentation. A high school biology 30 and chemistry 30 will be required prerequisites for this program. Only the geology field school is required as part of this program. However, paleontology and earth science field schools are highly recommended. If you have access to these valuable hands-on experiences, why not take advantage of them? Because there are not many universities where students can say that they dug for real fossils as part of their undergraduate degree. For students interested in urban and regional planning, there are 2 degree types available. Bachelor of Science major or honors in planning focuses on natural science elements, water resources, environmental management issues, such as impacts of development on wetlands, wildlife corridors, and naturally sensitive areas. Students learn how to use technology in planning, such as geographic information systems and remote sensing. The honors program is non-direct entry from high school, meaning students can start in the planning major before transferring to planning honors in their second year after completing specific courses. The alternate route would be the Bachelor of Arts with a major in planning. This program is suited for students who are interested in more of the aesthetic, economic, and social aspects of planning, such as building neighborhoods that are inclusive, sustainable, and enhance quality of life. Whether Bachelor of Science or Bachelor of Arts in Planning, both programs share common core courses, and either degree will allow students to pursue a career in planning and graduate as registered professional planners. Students explore not only the theory of planning, but also the application of planning, including the function of law, ethics, community involvement, and approaches to conflict resolution. Planning is a profession that works to improve the welfare of people by creating sustainable and attractive places for present and future generations. Students have the opportunity to engage in practical, hands-on study of community planning and development by taking on contracts with actual clients. For example, in 2018, a student project team was tasked with creating concept plans for the City of Edmonton light rail transit expansion in order to help lay the groundwork for long-term development to service more areas of the city. The final degree offered by the Department of EAS is the Bachelor of Arts in Human Geography. This program is offered as either an honors degree or as a Bachelor of Arts major or minor. The honors program is non-direct entry from high school, meaning students can start in the Bachelor of Arts major with Human Geography before transferring to the honors program after completing specific courses in that first year. Human Geography is a broad-based arts education, examining the diverse peoples, places, and cultures that make up our world, and the shared social and economic challenges we face. Working with leading geographers, students focus on real-world issues and challenges in areas such as housing, hazards, and health. A recent honors student looked at how we can prevent evictions in social and affordable housing to then prevent pathways to homelessness. Human Geography offers courses in cities and urbanism, spatial organization of local and international economic activities, geographies of health and healthcare, and the significance of cultural landscapes and shaping of social life by spatial arrangements. Students acquire firsthand experience of the world through field schools and research method courses. There are many career opportunities open to Human Geography graduates in government, nonprofit businesses, or community sectors, and various fields such as heritage conservation or the travel industry. So what's the difference between human geography and planning? Well, both disciplines share a similar passion for people and places. Planning is a regulated profession focusing on how cities should be structured and the laws and bylaws surrounding development, whereas human geography is more of a social science, examining the relationship between human societies and the environment in which they live. A simplified example could be that a human geographer can survey whether a growing community's healthcare needs are being met by the number of healthcare facilities available to them. And a planner can determine whether it's possible to build a new hospital on an existing green space with minimal environmental impact. As you've just heard, there are a lot of different ways to study the Earth within the Faculty of Science and Faculty of Arts. Here's a nice summary table of these subjects and whether they're offered as a major, minor, or honors, what the prerequisites are, if any, and whether they are non-direct entry. So feel free to pause the video and screenshot this information if you'd like. The prerequisites listed here are not necessarily required for admission, but will be required in order to register in higher level courses within the program. And I'll go over admission requirements shortly. So as you can see, for the most part, taking grade 12 biology, chemistry, and physics will allow all doors to remain open if you're still unsure on which program you're interested in. The U of A is one of the very few universities in the world ranked as making a significant impact on sustainability, thus playing a leading role in solving global challenges. EAS students can opt to add a certificate in sustainability to their degree. As an embedded certificate, this means that you count courses that you're already taking for your degree towards the certificate, so why not add it? Other relevant certificates can include community engagement and service learning, or economics and management of natural resources, energy, and the environment. Certificates on top of your degree will give you a welcome edge when hitting the job market after graduation. And beyond improving your resume, certificate students gain access to professional development and networking opportunities. The U of A is a leader in online learning, developing massive open online courses, or MOOCs, where students can learn from experts through interactive online modules at your own pace and even get credit for some courses. Mountains 101 and Dino 101 are two of the top-rated MOOCs in the world and were created right here at the U of A. Other MOOCs include paleobiology topics, Arctic climate, and our brand new course, 21st Century Energy Transition, created in partnership with the Canadian Society for Evolving Energy. And this 6-module course explores the roles that energy storage must play to support the transition to more diverse energy sources. Internship and co-op opportunities integrate university studies with relevant paid work experience. Minimum placements can be between 4 months to 18 months, depending on whether you're in a science or arts program. We host resume and cover letter workshops to help assist in connecting students with companies for work-term placements. And placements can be local, provincial, national, or international. Students are actually more motivated and focused to complete their remaining courses after gaining insights into the professional world through internships. And an internship can add time to your degree, but there are major benefits, and it's an ideal way to start building a professional network and figure out what you want to do with your degree while still in school. And outside of the internship program, students may also get summer research assistant jobs in a professor's lab or as a field assistant for graduate students. What can I do with my degree? The short answer, a lot. I can't possibly list every job available, but some would include environmental health officer, terrain analyst, digital cartographer, paleontologist, museum curator, city planner, and so many more. And did you notice how many industry examples I've given throughout this presentation that are right here in Alberta? You won't have to go far from home to find a job. And you can also visit uab.ca/science careers to see a longer list of potential career opportunities, as well as some companies that our students have worked with during their internship placements. Let's talk about admissions. Admission to the Faculty of Science is assessed on your marks from 5 core high school subjects. All science programs require English 30-1, Math 30-1, 2 grade 12 science courses, plus 1 other course. I've highlighted biology and chemistry 30 because, as I mentioned in the program slides, many of these will require one or both of these courses as prerequisites. I strongly recommend that you visit uab.ca/sci-prereq for a detailed breakdown of which programs require which courses. And you can visit uab.ca/programs for a list of specific admission-based courses that fall under that final course category of fine arts, humanities, and languages other than English. Admission to the Faculty of Arts is different than the Faculty of Science. A Bachelor of Arts with a major in planning requires English 30-1, Math 30-1 or 30-2, Social Studies 30-1, plus 2 other courses. And a Bachelor of Arts with a major in Human Geography is quite flexible in that the only specific course required is English 30-1, and the other 4 courses can be from a variety of subjects. And again, you can visit uab.ca/programs for more details. There are many ways to keep in touch and continue your U of A journey after today. We offer virtual advising sessions for prospective students, which can be scheduled at uab.ca/advising, and you can find digital copies of our view books at uab.ca/pubs. You can also visit uab.ca/recruitment events for a list of upcoming virtual and in-person events. And if you have any questions about our Faculty of Science programs, please feel free to contact our student recruitment team at science.recruiting@ualberta.ca. Thank you so much for being with us today, and thank you to Professor Marie-Gingras for providing some valuable information on the field school opportunities available to you. So we look forward to seeing you at the University of Alberta.